Thank you for being here. Our presenter today is MetaFab for Manufacturing Month. But before we begin, we'll just do a little housekeeping, and let me share my screen. So just a little housekeeping. Please make sure to check in, and this is the QR code. If you could use, you can use your phone to QR code or the bit.ly link. And don't forget to do the scholarship. There's a $500 for students, and I think teachers and 2 middle school teachers. And if you have any questions, make sure to ask. And if you don't know how to formulate a question, we have a great question documents. It's the QR code and the bit.ly link. And most importantly, do not forget to do the evaluation right after this event, so you can make sure to give a good evaluation. And be fully present. Do not check your phone. Don't text anybody. But ask questions. Either you can actually turn on your camera, because we know now that you're not when it's recorded, it's not showing your face, but it's nice to see who's on that name and not just a black screen. And again, make sure to do the evaluation, because that is your attendance, so we can track who attended. So you check in, but that doesn't mean that you are in the attendant. Like, you need to do the evaluation right after. So we'll have Tony at MetaFab now to do the Manufacturing Month.
Hey, thanks a lot. Welcome, everybody. Thanks for having me. I'm excited to share with you today a little bit about myself and my company MetaFab, and tell you a little bit. My hope is to tell you how I got here, how others find themselves in manufacturing, and what exactly it is we do here at MetaFab and where we fit in the larger manufacturing landscape. So when I was asked to present, I thought it was going to be Washington County or maybe the city of Hillsborough. I recently heard that we've opened it up and shared the link to all of Oregon. So if I could ask, maybe drop in the chat what high school you're with, or whereabouts in the state you're coming from, so we can kind of get a good idea of where folks are coming from this morning. With that said, while you guys do that, I'm going to share my screen, and juggling a couple different technologies, so bear with us while we get this sorted out. And if you have any issues with what you're seeing on your end as far as clarity or things not coming through, let me know. You can raise your hand, in the chat, or hit the mic and let me know what's going on. And the worst case scenario, I can always send the presentation to the facilitators, and they can send you whatever it is you are looking for. So with that said, we will get into it. Today, the talk's called Screen to Machine, and basically it's who and what does it take to get a fabricated part, to make a fabricated part. And what I mean by a fabricated part, in our world, it's sheet metal. So, taking large blanks of sheet metal, cutting them out, forming them up, and what do they ultimately become? So today's agenda, my hope is your takeaway from today's conversation would be an understanding as the different types of sheet metal that are out there. It ranges from structural sheet metal, which we all come in contact with in large commercial buildings or schools, thinking of stairways, railings, large heavy steel. We don't do any of that here at MetaFab. We do real thin gauge. So the whole world goes from large structural sheet metal all the way down to really thin gauge sheet metal, making boxes and enclosures. I also want you guys to get to know your local friendly neighborhood fabricators. And if you're coming from across Oregon, then your local statesman fabricator. Also, I want you to understand the whole process from design intent all the way through to the quality inspection and delivering good parts and what it takes. We'll take a look at a couple examples of what it looks like as parts go through the different processes. And then at the end of the day, hopefully I'm leaving you with some resources, where you guys can learn more, maybe classes you guys can be taking as you think about the next level of, whether it's community college or a four-year university, or going straight into the workforce. So we will jump in here. MetaFab. So our company is MetaFab. Like I said, we're a precision sheet metal fabricator. The company started in 1983, supporting local measurements manufacturers here in town. The company was purchased in 2002 by my father. It's a family-ran business. And at that time, when my father bought the company, it was there was 4 employees. We occupied about 5,000 square feet. And we've now grown to over 50 employees, and we occupy 31,000 square feet. One thing we're really excited about is of those 4 original employees, 3 of them are still with the company today. That says a lot about the culture and the environment that we've built here, and we're really proud about that. In 2020, we won family-owned Manufacturer of the Year through the Portland Business Journal. Again, really proud of that. The type of parts that we make, where do they ultimately end up? Any and everything that's sheet metal, we generally do. But some projects of note, we found out after the fact. They don't share it with us beforehand, but some of our parts did go up on the SpaceX Falcon rocket. That's probably the most noteworthy and exciting project. But we do everything from Mercedes van conversion kits to consumer electronic security devices. When you go into like a Best Buy and you pick up your iPhone, the metal brackets that are holding that phone on there is stuff that's made right here in Hillsboro in our shop. So yeah, I've got some videos here. Like I said, it's the technical side of it. I'm gonna see what I can do to share that, and let me know if we have any issues on your end. So I'm gonna hit play here. You can let me know if you can hear it all right.
MetaFab is a quick-turn, innovative, single point of contact metal processing facility. And we have the ability to take people's ideas and then turn them into a reality.
Pre-concept to completion, we're here as your contact to get your products to market, because it goes beyond just processing metal or just taking orders. We want to be a part of that solution.
The vibe here is very energetic, very positive, happy. You can feel that excitement of what's going on here.
One of the things that I like about working with MetaFab is that they can fabricate parts as fast as I can design them. And I can design pretty fast. Everything is under one roof. Any service that I need to fabricate a part, they can provide it.
I think the thing that sets MetaFab apart from most of our competition is our willingness to take challenges. It isn't about just today, it's not just about tomorrow, it's about definitely in the future of what we're really trying to build.
Things are changing, and today things are changing faster and faster than they changed, yesterday. And we invest heavily into new equipment, we invest into our employees, and both of those things is keeping us on the forefront of what the industry is doing.
What I see is a company that I can trust.
We're very customer oriented. We treat everybody as we would like to be treated.
I consider myself a very, very blessed man. I get to come in to a company and do something that I absolutely love. And I love sheet metal. I love working with people, and I truly enjoy what I have.
So that was a quick little video about who we are as a company, MetaFab, a little bit about me, your presenter, super genius. I did not pass 4th grade CPR training. So we wear a lot of hats here at MetaFab, and you know, they're always asking what kind of title I have there. So I always like to put super genius because just a little joke on, you know, do a little bit of everything here. But more on a serious note, you know, who am I and where did I come from? Like I said, it's a family business. My father bought it in 2002, but he has been in sheet metal since the late 70s, which means I grew up in and around sheet metal. When I was in school, you know, picking different career tracks that, or, you know, school options or what I was going to do after high school, I was really interested in architecture. And actually that comes from my time at Westview High School here in Beaverton with Coach Kamakaala. I'll show a video a little bit later about that. But basically, you know, I really enjoyed building things. I always wanted, you know, I like designing, and it just made sense that architecture was a great option for, you know, some of my natural talents. But that being said, those were kind of, you know, that was one of a few different options that were put in front of me. I didn't have a whole host of all the different possibilities available out there. So I ended up going to University of Oregon. I got my degree in architecture, professional degree in architecture down there. And then I worked and consulted for a few years and did some design work. And then eventually in 2010, I ended up joining the family business here at MetaFab. And for a while there, I ran a small e-commerce company where we made consumer electronics, making kind of flight simulator controls for people's home computers. And that was a lot of fun. Ultimately moved over to the metal side, and I'm in the process of business transition with my father taking over metal and the sheet metal side. So the reason I say all of that is I'm really focused and passionate about building manufacturing as a workforce for tomorrow, and more importantly, having these types of you know, speaking opportunities to share what manufacturing can offer. Because when I was in high school, no one was sharing that with us, and I think manufacturers as a whole have kind of dropped the ball on that ourselves. So you know, happy to be here and present many more options that you know, may not be being shared. So the next video I have for you, it's a longer video, but it highlights a really important conversation that I think the heart of this type of you know, forum is looking for. And it's a conversation I had with the Beaverton School District in the CTE program, and kind of basically some of the challenges that I just highlighted about what was available to me as a high school student versus, you know, what are guidance counselors talking about, what are high school students talking about, and parents talking about, and what other options are out there, and kind of weighing out all of the different pros and cons of whether a 4-year university makes the most sense, or whether going directly into the trades and then figuring out what certificates and degrees are needed, and kind of weighing that all out. So hang with me. It's a 7.5-minute video, but the folks from the Beaverton School District had done such a phenomenal job with the editing. They make me look great. I did my best to bring it down, but you know, it worked out. So it goes by fast. So here, we'll go ahead and swap over there.
So we want to try something else. So push, work together, CAD 2, CAD 3, portfolios next Friday, highly proficient grade, highly proficient work. Are there any questions?
This is Grads Talk and Shop. My name is G. Bundy, and I'm a teacher. That's me, and that's the Future Bus. We talk to former Beaverton students, and we learn about their career paths. Since they've left high school, they've been on their own journey, and they're all a little different. We listen to their stories so we can learn from their experiences. Today, we are heading out to MetaFab in Hillsboro to meet with Westview alumni Tony Varela.
My name's Tony Varela. I graduated from Westview High School. I work at MetaFab with precision sheet metal manufacturing.
So for someone who might not have a background in metal fabrication,
What could a day look like for you?
So what I do in the sales and marketing role is I actually get out there and I meet with a wide, diverse set of customers, and whatever products they're looking to fabricate, we can help them find that solution. And that means any parts that end up on commercial airliners, sports cars, even consumer electronics. Without anybody knowing it, you've probably come into contact with parts that we fabricated right here.
What did you do after high school? What did you think you were going to do?
Looking back at both middle school and high school, there was a couple courses that really stood out as things that I was really excited about. And that was generally shop. So in middle school, it was a shop class at Five Oaks. And then at Westview, we had an intro to CAD, computer-aided drafting with Coach K, where we designed a cabin and then we built a scale model of that. From his class, what really resonated for me was going from the CAD model we drew to building the scale model. Actually building something that was once in a 2D computer screen. I think that's where lights kind of went off and said, okay, that's where it really clicked. This is something that people do.
That's Coach K. He teaches manufacturing and design at Westview.
CAD 1, these dimensions, okay? They're not wrong, but if you have a lot of dimensions to put on here, it would get awful confusing. I would say, drag this dimension all the way through and put it on the outside. Here at Westview, our kids are able to do a ton of different industry skills. And we don't say, go master it. We say, expose yourself to it, immerse yourself, and when you leave our school, pursue your interests.
I ended up traveling for a year, and then after that decided college was the next step. And because of that shop class with Coach K and building and designing a cabin, I really took to architecture. So I actually went off and got my degree from the University of Oregon in architecture design. I went down the architecture road, and then I went out and did some consulting on my own. After that, I decided I would come back and work for the family business in sheet metal manufacturing.
Do you have to have a degree to start working here?
No, you don't. And I mean, I think that's probably one of the things I want to really touch on, the most, is that you don't even need the degree to become an architect like I thought I did when I graduated.
Interesting.
It's a great thing to have, and it definitely affords you a certain fast track in some regards, but it wasn't until I started working with my first architecture firm that I found that there were others that decided to go directly into the workforce. And they started with being a draftsman, and they got sponsorship from the company, and after they put together a certain amount of years of earning an income, but also gaining valuable job experience, they were at the same place I was with my advanced degree, and we could have both become architects. So roughly the same time frame. So one had 5 years of earning potential, and the other one incurred a lot of school debt.
Let's go there.
Yeah,
let's
absolutely.
talk about school debt. I think this is a conversation that we're really wanting to have more and more, and with more transparency.
I'm coming up on 20 years removed from high school, and I still have 2-3 years left of paying off those student loans. Again, a lot of good skills that I learned from college I take with me into manufacturing, but again, that's quite a big debt load to carry for 20 years, and I don't think a lot of people realize that, there's a lot of other avenues to take outside of high school than going directly into college. Maybe get out into the workforce and find something that you like to do, and then you can realize what certifications or what degrees are required for that, and then you can actually get sponsorship through your employer, or you can utilize other programs that are available to you and just end up with a less of a debt load, but then also earning potential along the way. One thing I've been thinking about a lot lately is I now have kids. I'm starting to have conversations about their college and how much we have to save for. And our financial advisor told us to plan for $250,000. And I told him absolutely not. I don't know how you ever make that money back. Something's gonna have to correct. It's either gonna be the trades or it's gonna be other options.
So in going through the shop, we saw all sorts of different processes, technologies, a lot of different roles. How does it work when someone wants to come and work for MetaFab?
A lot of the positions we have We consider them entry level, and really what that means is that you're going to get majority of your training on the job. That's one thing we talk about a lot in these meetings with school districts. They always are asking, what can we teach our students today that will help get them ready for a life in manufacturing? Well, what kind of mathematics skills can we give them? What kind of physics or science? And really the answer we keep coming back with is just the soft skills. Some folks were even just working on handshakes and just being confident in, you know, who you are and where you're at, and understanding that what you're bringing to the table is, you know, is just that. It's yours, your own story, and just be, you know, showing up and present and eager to learn.
All right. I hope you guys enjoyed that video. I think, you know, it's, like I said, a pretty poignant topic of, you know, what a lot of people are talking about these days. And, you know, it just shows that there's different pathways out there, and, you know, no one way is the only right way. And yeah, so anyway, let's dig into a little bit about manufacturing, and we can come back to that conversation, you know, more towards the end. So what we talked about within manufacturing and where, you know, where MetaFab sits is, you know, you start with the whole process. There's the design process, and there's fabrication, and then there's that quality inspection. And if you look on that image there on the right there, material comes in large flat sheets, and then it gets designed in a computer program, and then it's cut out in those big shapes, and then through different equipment that we'll see a little later on here, it gets formed up into these, you know, the different shapes there, to be used in boxes and chassis, electronics, and all sorts of products. So we'll dig into the design side. The design side, how many of you have taken any kind of CAD classes or design classes within your high schools? And you can, again, leave it in the chat. What kind of software are you guys using? Give you a minute here if you want to drop some comments. So I've left a couple options here on this slide that, you know, some of them are available to, you know, high school level folks. Some of them are used in a much larger business scale. AutoCAD is what I used, was what you saw the students using at Westview High School, and that's what I've used with Coach K 20 years ago, and it's been around a lot longer than that, but still used widely with drafting. Fusion 360 is a great tool through Adobe, and I think they have a free student version. So, you know, if your shop classes aren't already using that, you can talk to your shop instructors and, you know, see about getting some of those copies, because that program allows you to do like mechanical 3D design, and then you can export those to different software to allow to program to machines and actually fabricate parts. And then of course, SolidWorks. SolidWorks is it's kind of the industry standard. It's what we use at MetaFab. It's what most manufacturers are using these days. But oh, someone joining. So yeah, it's what most folks are using. But again, all three of those can get you where you need to go. And with the CAD software, generally what you're doing is you're putting together a set of blueprints. They're not blue anymore, they're generally white, but blueprints is just a way to translate that language of the design intent to the fabricators of how these parts get made. And so there's a couple key items that you want to include on all your blueprints. That being, you want to, your different views. So there's your 2D views, which is generally a top view, side view, left, right, with different dimensions. Then there's a 3D isometric view, and think of that as like a perspective view. So you've got one face, and then your other face is trailing off in the background. So it kind of gives you a better, more 3D kind of, 3D view. You also want to include the critical dimensions, materials that you're going to use, and finished specifications. And that's the kind of information that we're always looking at every day, reading different blueprints, different prints from all of our customers. To give you an idea of where MetaFab fits in that, I was talking about precision sheet metal, the opposite end of the structural heavy gauge, stairways and railings. We do the thin gauge small stuff, and we're dealing in precision tolerances, dimensions of 5/1000ths of an inch, 10/1000ths of an inch. And to give you a good idea of how small that is, a piece of paper is about 3/1000ths of an inch, if I have that correctly. So basically we're dealing in, half a sheet of paper to 2 sheets of paper when we're talking about lining up different features like this edge of a hole to the edge of a part. I've got a sample part here. Maybe you guys can see this or not. Can you guys see me? Give me a thumbs up or give me a chat if you can see my video or just my shared screen. Okay, you can see me. Great. So here's a sample part where you got the different holes in there, and so we're talking, the dimensions of these holes here to this edge, or from top to bottom, can be measured within 5/1000ths of an inch or 10/1000ths of an inch, depending on the equipment we're using. So give you an idea of how tight we get. So next we look at the process. The process is used within sheet metal fabrication. We've got everything from, of course, we bring in that material in large flat sheets, and then that has to get cut out. And there's generally 2 types of ways you can cut that out. We call it our cutting centers, and that's generally laser cutters or large hydraulic punch machines. So that's cutting, and then the parts move to deburr, where you're shaving off all the sharp edges from what you had just cut out, and think of that as just a lot of sanding and grinding. And then there's forming, and the forming is, so here's the sample parts I was going to talk about. You saw the last one. It's just like a flower vase or a candy dish, but that's the formed version. We did this one all by hand just to kind of show, but here's a powder coated version of it in the flat form. So what I was saying is this one's all cut with the laser. So the laser cuts out all these different shapes in the flat pattern. So it comes in one large sheet. We cut a whole bunch of these out, and then through the press brakes, it's a tool and die that comes down, forms up the different flanges that you need into a shape like this. And so forming, there's hardware insertion, which is like self-clinching, nuts and screws, and welding and machining and finishing and assembly. And finishing is powder coating. Like I mentioned, it's applying like a plastic powder, and then you bake it at 425 degrees, the same temperature Love's baked at. That's a Papa Murphy's reference. And the plastic powder basically melts to a nice solid coat around the part, and that's primarily used for corrosion protection. So we'll go ahead and jump through some of the processes here, and then what I'll try to do is translate like what kind of skills you would want for each one of these areas, or what operators need to be aware of for each one of these processes, kind of help you get an idea of what people are doing. So as I mentioned, here at MetaFab, we have a 4,000 watt fiber laser. That's exactly the piece of equipment up in the picture there. So operators generally have to be, pretty good with, operating systems, user interfaces. I mean, if you work any of your social media apps or your phone, you're halfway there. So I don't have any suspicion that any of you would have any difficulties with that. It's generally people like my folks' age who, are just punching buttons and have no idea what computers are. So it still exists, I promise. Then the other one we have the cutting is the punch turret I'd mentioned. Those are large hydraulic punches. It's a tool and a die. It's a top piece and a bottom piece. And basically it's just large hydraulics that come down and then punch the metal out into different shapes. We can punch up to 30 tons of pressure in one of those punch machines. We have 3 turret punches here at MetaFab. Graining and deburring is, like I had mentioned, it's sending it across a sanding belt or a graining belt that just removes a layer of the material, removes the sharp edges. We also have some automated cobots that help us load some of these machines, which is actually pretty exciting in new technology. So as we're getting into kind of industry 4.0 and everything's becoming wireless or automated, that's a little bit of room where MetaFab has started seeing some automation. And that's been a lot of fun with that project. I mentioned earlier that when you have the cutout part, the outline, you have to form it up into the different shapes. That is all done on press brakes. Press brakes, we have you know, we can do up to 80 tons of pressure of bending this thick material, and we can bend up to about a 1/4 inch thick of material on our press brakes. There's much larger press brakes that are forming much bigger pieces of metal, but we stay away from those kind of thicknesses. Again, you know, all of these different areas are going to be, you know, operators that like working with their hands. There is some user interface that, you know, you have to be, you know, good with. It's just selecting programs, loading the programs, and then a lot of it is working with your hands, setting up the different tool and dies, and then, you know, apply. You know, what you do is you take your piece of metal, you set it between the tool and the die, keep your fingers nice and clear, press on the pedal, and then that forms, it just basically takes that and then forms it up into the shape that you need. And then you pull that out, put the other one in, press down on it, and it forms that up into the different shapes that you guys need. So the hardware insertion, same sort of thing. It's just a hydraulic press, presses the hardware, and that allows people to take the electronic motherboards or any kind of circuits and whatnot, and then screw that into the electronic enclosures. So think of your computers at home. It's all built with a sheet metal chassis, structural components internally. If any of you have built a computer, you know exactly what we're talking about. You take off those side panels and there's a sheet metal structure that has screws, and that's where you're screwing your motherboard on, your power unit, your cooling fans. That's exactly what hardware insertion is. We do full welding here. A lot of high school courses are, you know, teaching welding with, you know, arc, MIG, and TIG, and you know, that's, you know, there's a lot of opportunity there. A whole lot of you know, different welding types you can do. Again, we do real thin gauge sheet metal, so applying a lot of heat to really thin amounts of metal causes a lot of material to warp. And so it's a difficult side of the welding. I like to think of it as kind of the grade A, you know, level welders that we work with. The next steps, we have machining, and I had mentioned powder coating and assembly. Machining, you hear a lot about these days. It's called subtractive manufacturing. A lot of college courses have what they call subtractive manufacturing or additive manufacturing. Subtractive manufacturing is where you're taking a block of material and you're using mills or drill bits essentially that remove the material away from the block along designated program paths. That's subtractive material. You're taking subtractive manufacturing as you're removing the material. And then of course the hot buzz of the day is 3D printing, which is additive manufacturing. And that's actually applying material to a template and then building up your part from that. They are starting to 3D print sheet metal, which is really exciting. It's essentially just layering weld after weld of material. But there's a lot of excitement around 3D printing. What we primarily do is just called flat work, and that is, you know, like I said, forming sheet metal. Powder coating is applying a plastic powder that then, you know, bonds to the part, goes through our large industrial oven and bakes at 425 degrees and just melts together in a real strong, durable finish, again, for corrosion control. And then we have assembly, and I got a little photo here of Lego figures being assembled. I mean, I love Legos. I still, 40 here, and I still collect some Legos, and I build Legos with my kids. I've always, said if you like building Lego sets, and the assembly is something that you would really do well with and enjoy, following the instructions and then just building, using screwdrivers, nut drivers, those kind of things, just to assemble the fabricated parts that we fabricate here, pulling them together and building larger assemblies that then get sold to our customers. So that is basically the process of all the different steps that we do here at MetaFab in sheet metal manufacturing. Before I jump into quality and talk about that a little bit, I just wanted to throw it back to you guys, see if you guys have any questions. And at any time during the presentation, you can, of course, raise your hand or drop a chat. And okay, great. I got a question right here. Where do you get the material? Is it sourced locally or international? That's a fantastic question. Much bigger conversation, but I'm happy to have that. You may or may not have heard a couple years back, a lot of talk about tariffs. There was international trade policy going on, and the president was putting tariffs on Chinese imports. our material specifically comes from primarily North America and Brazil. But that being said, when we limited a bunch of the raw material that was coming overseas, that made everybody else's material become much more scarce. And so that's a bigger answer, but we source locally. Our distributors source from, North American mills. But that being said, there's mills all over the place, and supplies right now are all sort of haywire. So we're all kind of scrambling to keep up with that game there. Great question. So again, if you have any more questions, keep them coming, and I'll try to jump back and forth to the chat and talk about, answer those questions for you as we keep moving through. I don't want to feel like I'm just talking at you the whole time. So the next one we talked about was quality and inspection. So we went through the design part. You use CAD to come up with the ideas and then figure out how this thing's going to come together. And once you've used your computer-aided design software to model it in 3D, you unfold it to make sure all your dimensions are correct. And then you come to a manufacturer like MetaFab and you give them your prints and say, all right, have at it. You're going to manufacture this for us now. And we go through all those many steps that I just shared with you. And then you got a finished part. And at the end, you have to make sure that that part meets all the quality specifications for your customer. Here at MetaFab, we prescribe to ISO 9000, which is an international quality standard, and it just guarantees that we're following the same processes every time when we have a parts or a project that comes through our shop. That machine that you see on the left there is called a CMM. It's a coordinated measurement machine. Basically this one's really cool. You have that handheld wand, and it casts a camera to your part that's on the tombstone, and you place the probe on the different parts, and it can measure up to 1/1000th of an inch, which is, I don't even know what that is in millimeters, but it's still fractions of a millimeter even. And that gives us just a real precise measurement of how these parts are turning out. And so we like to say at MetaFab, we deliver confidence 100% right, 100% of the time. And this is our ISO certification. And then we're also ITAR registered, which is also a quality standard for mostly for government work. It stands for International Trades and Arms. And so as you can imagine, there's some government contracts that require that kind of designation. So with quality in mind, of course, got to reduce mistakes. And mistakes do happen. And so part of that ISO standard is talking about what do you do as a manufacturer to, there you go, great. What happens when something doesn't meet quality standards? Is it thrown away or recycled? Both of those, so it's recycled. Worst case scenario, all of our material does get recycled. There's a couple steps that happen before we have to make that decision of whether we have to recycle the material and then rebuild that material. Oftentimes you can salvage a part if it's out of tolerance, or if something's incorrect, you might be able to rework it. And that's a conversation with your customer that you're having. To give you an idea of the level of requirements that we're held to, we kind of measured in parts per million, which means we may not do 1 million parts throughout the year, but you take a ratio based off of how many parts you have going through your shop and how many parts are bad. And a lot of the goals that we have are, it's the tens of thousandths of a point. So our goal is 99.95% of the parts that leave our shipping doors are good, and we don't hear from the customer again on any bad parts. Some do slip through. But to give you an idea of 1 million parts, that's 500 parts that are bad if you're hitting that number. And we are a little bit larger than the 500. We're right now we're at 98.7. So not too far out of away from our goal, but we keep working towards that goal, and it's a very small percentage. So it gives you an idea there. To measure the parts, I had mentioned we have that CMM machine, but then we also have calipers, depth and height gauges, micronometers, that's a hard one to say, and then Granite QA tabletops. And the reason we use Granite is it is extremely smooth and flat. So you can place a part on that and you know that over the course of 4 points, do you have a flat, planarity, or do you have some sort of warpage and wobble? And those are, just tools that we're able to use to see how much, how out of tolerance we are. And most parts you're allowed, I say tolerance, that means, you plus or minus a certain amount of, distance that you're allowed to be within. So that's the kind of space that we're operating in. For QA standards, I think a QA engineer, somebody who is meticulously detail oriented, is going to be, they're going to thrive in that position. Just making sure that all of your T's are crossed, all of those I's are dotted, and that's something that, and then pouring over a lot of data to make sure that that stuff's right is a great spot for somebody who is looking for that type of work. So we are kind of at wrapping up towards the end of the presentation. We got what's next. Like I said, hopefully I can leave you with some resources and some of my opinions on some possible steps forward. Of course, what's next? You can take more courses. A lot of speaking to high school students, a lot of high schools are focusing on different areas of technical education paths. You can always, choose one of those and take a couple courses to see what you like, see where your strengths are. I always recommend, and I try to push educators when I'm having a conversation with them, that we leave it as flexible as possible and allow people to really explore and not get too, narrowly focused on what that track is. Because I think that's what happened with, architecture in school. Is like you go out and you pick that degree and then you finish that and you get out and it's like, all right, all that's left is architecture. But there's a whole lot more that's available out there to you, and having that ability to explore is really beneficial. So you can, once you graduate, you can go to local community colleges and take some courses that are manufacturing related courses. I like that option because it allows you to get your feet wet and see what works best for you. The other option there is you can start in the workforce, and I'll have a slide about this later here. We're going to watch this video first, but again, I really like the idea of like starting, maybe getting a job in an area that you may like, finding out what certifications and requirements are required. And then you have some other different possibilities where maybe a company sponsors you and sponsors the education that you need afterwards, and they actually fund your college or your university experience if that's the possibility. So who's hiring? Well, I've got 2 links there. MetaFab, of course, we're hiring. We probably have about 5 positions available for entry level, where we're going to get you in here to train you up on how to read blueprints, how to do a lot of the processes and operations, and then you can work your way up to programming and, actually working in the CAD and working with the customers design and create the parts. So our link is there. And then also I've included the Hillsborough Chamber. It might be an old link, so I can get a new link for you guys there, but that's another possible resource to a lot of other manufacturers who are hiring, and there's so many here in the Washington County area, I can guarantee that are looking for work. And so there's a lot of possibilities there. So I'm gonna pop over. Great, there's a link of the new website. Fantastic, yes, thank you. Oh, that's right, Washington County. That one's still new to me too. So anyway, I'm gonna pop back over. We're gonna watch this last YouTube video, and this is of a course that is taught at PCC, our local community college. And one of our colleagues here is actually an instructor of this manufacturing and drafting course. And so let's go ahead and watch that, and we'll pop back over here to close it out.
I'm intending to take just 1 class or 2 classes and got really excited about what other potential there was.
You can get yourself into a good paying job in a fairly short time frame.
I'm planning on being a private contractor.
It was everything I thought it could be and more. CAD stands for Computer Aided Design and Drafting. basically modeling objects or parts in a 3D space on your computer. You can use CAD programs to model everything from a Rubik's Cube to a chair. You could be designing things for IKEA, for Boeing.
With PCC's one-year certificate program, you're going to learn practical knowledge from those who work out in the field. You're going to learn modern manufacturing techniques, and you're going to learn the latest computer software.
The field itself is very, very big.
You can go into so many different fields just knowing how to use software like AutoCAD, Inventor, SolidWorks.
By far my favorite class was the 3D printing class.
You design whatever you like, and then you are able to put it into a 3D printer, and you can make it come alive.
The best part is the instructors, really. They keep the class lively, keep it fun.
They're keeping us up to date on what when you leave this program, here's what you need to do in order to get this job.
Whether you're really creative and artistic or you're super meticulous and have an eye for attention to detail, everyone's got a place with CAD.
I'm looking forward to learning more about what kind of jobs are really out there.
As an engineering manager in industry, I'm always looking for that student who has been through the CAD program, who's had the same training that I had.
About a year ago, I got a pretty good job using some of the skills that I've gotten from the CAD program.
My plan right now is to use the CAD program to prepare for a master's program.
I am a CAD designer because of PCC.
I came in.
All right, so that's a course that's taught by Adam Scheibel. Like I said, he's our engineering manager here at MetaFab. There's a great question that came through the chat. Excuse me, came through the chat. Do you offer internships? We have a kind of quasi internship program that we've put together kind of unofficially. We don't have an official partnership with PCC. Therefore, I don't think it's not in exchange for credits, but it's a full paid internship that we offer. We use the term internship because with specifically those types of drafting and engineering students, we are trying to look at it as a opportunity for them to work with us and get a good understanding of what manufacturers are looking for and building those skill sets. And then the idea is that, it's a 6-month contract essentially. And at the end, we either have the option to hire full time, or ideally they, go on to the next gig. And so the idea is that we constantly have a seat that's kind of revolving with customers with students coming through. And so again, not an official internship program where we're exchanging credits for time. It's just, I guess it'd be a paid internship. And the idea is that it's a time-based contract. Now, we have hired three or four candidates out of that program, and we probably had as many go through and finish that 6-month contract and move on. But they often go on to other customers of ours, and we continue that relationship and working together. So it's been a good program, beneficial program. The other question right above that one, which is another great one, is what is the average income for an entry-level job? It's a fantastic question, one that we're all very curious about. Right now, MetaFab starts almost everybody at $17 to $18 an hour. That's quite a bit higher than the $7 an hour I was making, 20 years ago now, so that's a long time ago. But yeah, I know a lot of talk right now, locally, of course, in Portland is, $15 minimum wage. And, we have to, we've never paid minimum wage as long as I can remember here at MetaFab. And so, in keeping up with that, we start you off a few dollars more than the minimum wage. But the earning potential here is, we have engineers and leadership positions, management positions that, can make close to 6 figures or low 6 figures. And so there are plenty of opportunities to grow within both here at MetaFab, but then also in manufacturing, across the board. So I wanted a couple more slides here, and kind of wanted to propose a tale of two tales. And this goes back to the conversation I was having with the Beaverton School District and Coach K about what you do after high school. And so basically, I'm calling this the outdated approach, and some of the educators out there might, hate me for this, but what we've traditionally done here is, you've got your options of you graduate high school, you apply for universities, you get in your university, you then select a major, and then you go on and do your intern or you're working part-time in that field. And then you get out and you hopefully love that field, and that's what you do for the rest of your life. But I don't know what the exact stat is, but it's pretty large that most people end up working in a different field than what their major is. And I'm part of that piece as well. So I've always proposed a different approach, and going back to that conversation I had with the CTE program, what I hope the takeaway is that I'm not anti university or four-year degree. I very much believe in that. I just think the way in which we rolled out the timeline for people to make those decisions, for students to make those decisions, is a little outdated. And what I mean by that is the option I propose is graduate high school, work for a local company, figure out exactly where you find yourself, drawn to or passionate about, and then figure out if you love it or hate it, and either make a change while you have little invested in that company or in the time, or you find out you love it and have a conversation, more importantly, have a conversation with the company and say, hey, what certifications are needed? What degree is needed? And then, if you could talk with the company and figure out if they'll help pay for the college education, then, that's huge bonus points. Or you can just find other programs to start school and make that happen. So, yeah, so those are kind of the two, possibilities I like to throw out there. Like I said, when I was in high school, it was, I was, basically, here are the two colleges you get, OSU, U of O. Here are the programs that they each offer. Choose something. And again, I did some traveling and took a year off, but then decided, hey, I was pretty good at architecture. I'm good at drawing pictures. I can go do that program. And that was my choice. So that's all I have for you today. Looks like we're probably getting up against time. I might have gone over a little bit. I'll leave my contact information there for you, phone number, email address, and our website. Feel free to reach out to me if you have any questions. We'll go to our website. There's a careers page at the bottom. If you're looking, I don't know what year everybody is, but and we're also in the beginning of the year. So come next summer when, if you guys are graduating, you can take a look at our careers page and drop us a line. I will stop sharing my screen now and kick it back to you guys. All right. Thanks so much for letting me present today, and I hope you